Hey guys, this is Miss Mo. We're going to start off on these problems where we change these decimals to a fraction form of A over B. So first, for part A, let's say that this one number they gave us is the letter X. So X equals 0.7 with a repeat. Now what I'm going to do is I'm going to count how many digits there are that are repeating, and there's one digit that's repeating. So I'm going to multiply both sides by 10 to the 1 because only one number repeats, or that's another way of saying just 10. So I'm going to multiply both sides by 10, and we get 10x equals, and when you multiply something by 10, your decimal moves once to the right. So instead of 0.7, the decimal now moves once to the right, and we have 7, then a decimal. But then what about this part that's repeating? Technically, it's there. Always. Always. So this 0.7 with a repeat, if I multiply it by 10, it moves the decimal once to the right. So we get like 7 repeat with a decimal, but that's weird. We don't usually put a repeat on the left side of the decimal. So instead, we put 7 point, and then what's going to come after this? Is it going to be a bunch of zeros? And the answer is no, because it has that bar on top of the 7. There should be more 7s after it, repeating. So this 0.7 is going to become 7 with a decimal, because that decimal moves once to the right, but then it still has a repeat on that right-hand side of the decimal. Okay, so now what you're going to do is you're going to subtract them. So we're going to say 10x equals 7.7. And then I'm going to take and I'm going to subtract off this original business of x and 0.7 with a repeat. And when I subtract off that original, let's see what we get. 10x minus a pretend 1x is 9x equals 7.7 repeating minus 0.7 repeating is just 7. So this is going to make, divide by 9, 7 over 9. Okay, and then if I do it again for 0.07, it's the same-ish thing, only we're going to have probably over 90 line. Let's check it. Let's take 0.07, where the 07 repeats, and name him X. Then we're going to say, okay, there's 2 digits underneath that repeating, so I'm going to multiply by 10 squared or 100. So if I multiply both of these by 100, we get 100x. And then on the right, the decimal moves twice to the right. So we get 7 with a new decimal, but then don't forget that 07 repeats over and over and over. Okay, now what we're going to do is we're going to subtract them. We're going to take this 100x, and we're going to subtract off the original x and the original 0.07 with a repeat. And when I subtract those, the repeat goes away. And 100 minus 1x is 99x equals 7. And then we get x equals 7 over 99 because you divide by 99. Okay, then this I, it's probably going to be the same thing, but 7 over 3 nines. And then part B, it's asking, what do you think this next one would be? Well, it's probably 7 with 4 nines. Yeah. Okay, and then part C, it says mentally compute a decimal. You can just put that in the calculator. Okay, let's do some more of this decimal changing business from a decimal to a fraction. Okay, let's maybe do part B over here with this 0.38 repeat. Okay, well, what we're going to do is we're going to say that's the letter X. Then I'm going to count the digits underneath the bar, and there's 2. So I'm going to multiply by 10 squared, or 100. Or I'm going to move the decimal twice to the right. So this makes, if I multiply both of these by 100, I get X times 100 is 100X. This sucker times 100 is the 38, with the decimal now moved to the right. And then after that, a 38 that repeats. Okay, now what we're going to do is we're going to subtract them. We're going to subtract what we just got and what we had at the beginning. And on the left, we get 99x. On the right, the repeats cancel and we just get 38. So 38 over 99. Woohoo! Okay, for part C, it's a little bigger. So I'm going to say that x is 0.553 repeat. And then I'm going to count how many digits are underneath that bar. And there's 3 digits, so I'm going to multiply it by 10 to the cubed, or 1,000, or 3 spots to the right. So if I multiply both of these by 1,000, I definitely get 1,000x. And on this repeat, the decimal moves 3 times to the right, so 553. But then that 553 is still after the decimal, and it's repeating again. Okay, now we're going to subtract our original x and 0.553. And we get 999 equals 553. And then divide by that 999. And then see if you can reduce. You might be able to reduce. Okay, woohoo!